So in this video we will study about the enthalpies of formation. So according to definition, the enthalpy of formation is represented by this sign, which is called delta. This triangle size is called delta. H small f. So delta HF. So enthalpy, change in enthalpy of formation, is defined as the enthalpy changes for the reaction in which a compound is made from its constituent elements in their elemental form. So for an example, if we are talking about the enthalpy change delta HF of carbon dioxide gas, it means how the carbon dioxide gas is formed from its element carbon and oxygen. How much energy is required to form this molecule, that is the enthalpy of formation. So let's see some other more definition about the enthalpy of formation. And there is one more enthalpy of formation. It's called standard enthalpies of formation. And according to standard enthalpies of formation, which is represented by delta H small f and small degree sign on the H as a superscript, are the measured. So standard enthalpies of formation are measured under standard condition. So this sign represents that it is measured as a 25 degrees Celsius and 1 atmospheric pressure. And the standard enthalpy of formation of the most stable form of any element is 0. What does it mean? It means, for an example, oxygen gas, nitrogen gas, and iodine gas. So enthalpy of formation of any formation of the most stable form of any element is the 0. So these are considered as the most standard or stable form of these elements. And this table shows some of the standard enthalpies of formation at 298 Kelvin. So this 298 Kelvin is exactly same as 25 degrees Celsius. So you need not to memorize these values, but this table we will use as a reference table, and usually the value of this formation is given in the question paper. And how we calculate these enthalpies of formation? So for a reaction, let's see that. So enthalpy of formation of any reaction is can be calculated using this formula, which is called sum. This sign is the sum. Small n is standard enthalpy of formation of products minus sum small m standard enthalpy of formation of reactants, where delta H 0 of reaction, this one is enthalpy changes for the reaction at standard conditions, and this is sum small n and m are moles, and delta H 0f is enthalpy of formation. So it means that we have to combine the enthalpy of formation of all the products, and then we have to combine enthalpy of formation for all the reactants, and then subtract from product to reactants, and then whatever the value will come, we have to present in with sign, and that will be the enthalpy of formation of reaction. So let's take an example and then we can better understand this. So calculate the enthalpy changes for the following reaction, where C3H8 gas, which is propane gas, and propane gas have CH3, CH2, CS2, this is the CS3, so 3 3 6 and 2 8 hydrogen, 3 carbon. Propane gas, when burned in presence of oxygen gas, it produces carbon dioxide gas and water molecule. So propane gas we use in the lab, and the enthalpy of formation for propane gas is given at standard condition. Enthalpy of formation of carbon dioxide gas is given, and enthalpy of formation of water is given. For the oxygen is not given. Why? Because oxygen is in its own most stable form. That is why enthalpy of formation of oxygen gas will be 0. So let's see how we will use this formula. How we will use this formula to calculate the enthalpy of formation for this reaction. So you can see, first we have to write the remember the formula, that enthalpy of formation of reaction is small n, number of moles, and enthalpy of formation of products minus small m, enthalpy of formation of reactants. So here products, first we have to write down, there are two products, carbon dioxide gas and hydrogen water molecule. So first we will write the enthalpy of formation of carbon dioxide gas, which is minus 393.5 kilojoule per mole, and there are number 3 coefficient in front of carbon dioxide gas. There we have to multiply this one, and then remember here is the sign of sum also. So this is the, we need to sum. So sum means we have to add enthalpy of formation of water molecule also. So 4 multiplied by, so enthalpy of formation is given for water is 285.8 kilojoule per mole, and then subtract enthalpy of formation of propane gas, and I can add plus oxygen also, but it will be 0. That is why we cannot add it here. So now once you will multiply these value, it will come minus 1180.5, and then once you will multiply this 4 into 285, it will come this number. But when you will open the parenthesis, this will come with the negative sign. And on here, so there is only 1 mole of propane gas, that is why this is 1 mole. We did not multiply with any coefficient. And when you will open the parenthesis, this minus sign will change to plus because outside is minus. Now we can add these two together and then subtract with this value, which will come at minus 2219.85 kilojoule per mole. So this would be the enthalpy of formation of methane gas if we need to make methane gas from the carbon dioxide gas and water molecule. So this is the way you can calculate the enthalpy of formation of this reaction. There is one more way to calculate the enthalpy of formation of a reaction using Hess's law. So same reaction, and if we will try to solve this question according to this reaction flow, that methane gas is burning and it is forming the graphite first, carbon and hydrogen gas and oxygen gas, and then the second step is this carbon dioxide gas is forming by reacting graphite with oxygen, and then third step is hydrogen and oxygen are reacting to form water molecule. Or in direct, when the burn in propane gas, it form carbon dioxide gas and water molecule, and we have just calculated the heat of enthalpy of formation of this molecule, this propane gas reaction. So if this is not given and we know the some other reactions which how in the stepwise formation, then we can utilize this Hess's law. Through Hess's law we can calculate the enthalpy of formation. So first we have to consider that the composition of the propane into the elements like carbon, graphite and hydrogen gas, and so hydrogen gas and carbon, graphite gas, and we need oxygen for decomposition of this one. That is why they have oxygen here also. And then for this reaction, the heat of formation is given here, and second step we can consider that formation of carbon dioxide gas, graphite which is carbon, when oxidized with or burned with oxygen gas, it forms carbon dioxide gas. So first step this one, second step from here to here, and third step we will consider that hydrogen and oxygen are forming together as a water molecule. So imagine the third reaction will be formation of water molecule, and then what we can do, we can combine all these three steps, that propane gas is decomposing into carbon and hydrogen first, and then carbon is reacting with oxygen to produce carbon dioxide gas, and then hydrogen is reacting with oxygen to produce water molecule. And we know heat of formation for each reaction. So therefore we can sum this reaction, and once we will sum this reaction, you can see we can write that there are 4 water molecules forming and 3 carbon dioxide gas is forming, and then 4 hydrogen and 4 hydrogen will be cancelled out, and then what we can cancel it, 3 graphite will cancel out, so only 1 mole of propane gas, and 3 and 2 5 mole of oxygen gas remain, and 3 mole of carbon dioxide gas will form, and 4 mole of water molecule form. So same reaction we got it, but in a 3 different steps rather than 1 direct step. So we will use Hess's law, and again the same, we have to use the same, we can use Hess's law in this way, that heat of formation will be sum of the number of moles of heat of enthalpy of formation of products and enthalpy of formation of reactants with a total number of reactants, and small n, m and r small n and m are the stoichiometric coefficient. So now we know that the reaction is this one, and each reaction have the value is given here, heat of formation for each product. So once you will combine, so you can see for oxygen is 0, so this side is the product and then reactants. So once you will calculate, it will come the same exactly at in the first direct step. So whether you go from the step by step or you can go for direct, the heat of formation of standard enthalpy of formation will be same. So this was the formation enthalpy of formation, and then you can solve some more questions to learn